Hi folks, in this video we're going to look at linear inequalities. First let's talk about what we mean by an inequality. Okay, as an example, 2x plus 3 is less than 11 represents an inequality. So similar to an equation where a certain expression is equal to a number or another expression, here we want to know for what values of x will this expression on the left be less than 11. Okay. So one way you can solve this would be with a graph. So you can take 2x plus 3 and sketch it as a line. So you know it'll be some positive slope, y-intercept of 3. And then here you can go to y equals 11. Okay, and figure out for what x values is it greater than 11, for what x values are the function values less than 11, less than or equal to 11. So this is one way in which you can solve an inequality, but it's certainly not an efficient way. Okay? So the question is can we solve this in a similar way that we'd solve a linear equation? Now we can solve linear equations by using opposite operations. Okay? So let's explore whether this can work. Okay? I think we can all agree that 6 is less than 8. Okay? So this is a true statement. Now remember what we can do with linear equations. We can add numbers to both sides of the equation. So if I add a number to both sides of the inequality, 6 plus 2, is that still less than 8 plus 2? Okay, and here, yes, 8 is less than 10, so that still works. What if I subtract a number from both sides? If I do 6 minus 2, is that still less than 8 minus 2? Okay, so 4 less than 6. Now I'm just showing one example each because I think these are fairly reasonable assertions to make. Okay. What if I multiply a number to both sides of the equation? So if I do 6 times 2, is that still less than 8 times 2? Okay. And I'm making them both bigger by the same factor. And yes, 12 is less than 16. Okay. Now, let's take a look at division. If I divide both sides by 2, okay, am I still going to keep the same inequality? So, yes, I do, because 3 is still less than 4. So this tells us that we can probably solve this inequality in the exact same way as we solve a linear equation by using opposite operations. So, let's try that here. 2x plus 3 less than 11. So let me subtract 3 from both sides. I don't change the inequality. So 2x is less than 11 minus 3 is 8. And now let me divide both sides by 2. X is less than 4. Okay. Now to see whether this works, let's pick some x values less than 4 and make sure they satisfy the inequality. So let's take x equals 3. 2 times 3 is 6, plus 3 is 9. Yeah, less than 11. You can take 3.5. 2 times 3.5 is 7, plus 3 is 10. Whereas if I take something like x equals 5, 2 times 5 is 10, plus 3, 13, that doesn't satisfy the inequality. Okay, so here we've got this expression represents all the x values that are going to give you 2x plus 3 being less than 11. Okay, so let's do, say, one more example to confirm that this works. So here, let's say I've got negative 3x minus 11 is greater than or equal to 1, say. Okay, so for what values of x is this greater than or equal to 1? So if we follow the same procedures before, so let's add 11 to both sides. Okay, so 1 plus 11 is 12. And then let's divide both sides of the inequality by negative 3. And here we end up getting 12 divided by negative 3 is negative 4. Okay? So this is saying that if x is greater than or equal to negative 4, the above inequality will be satisfied. So let's check something out. Let's check negative 3. That's larger than negative 4. So we get negative 3 times negative 3. That's positive 9. Minus 11 is negative 2. Wait a minute. That's not greater than or equal to 1. Okay? Well, let's pick something less than negative 4. Let's pick negative 5. Negative 3 times negative 5 is positive 15. Minus 11 is 4. Well, that shouldn't have been a correct answer because 4 is greater than or equal to 1. So there's a bit of a problem here. So let's go back to our example of 6 being less than 8. Okay? Let's say I multiply a negative number to both sides of the equation. Okay? So negative 2 times 6. Is that still less than negative 2 times 8? Okay? So here we have negative 12. Here we have negative 16. And we see that that does not work. Okay? So I have to be careful here, because while we are increasing the absolute value of the left and right by this factor of 2, by making it negative, now we have the opposite scenario. Here negative 12 is greater than negative 16. Okay? So that means that there's a little hiccup in our procedure, but it's easily fixed. Okay? You can solve a linear inequality by using opposite operations exactly like you did a linear equation. However, if you are multiplying or dividing by a negative number, you have to switch the inequality. Okay? It will give you a different relationship. So here, when we divided by negative 3, this should have been less than or equal to negative 4. Okay? Now you notice here that all these inequalities have more than one solution. They have a range of solutions. Okay, so one way we can represent the solution is using a set, using set notation. So this would be represented by x, an element of R, such that x is less than or equal to negative 4. Okay, you can also use interval notation. So x is an element of the set that goes from negative infinity to negative 4, in this case here, inclusive of negative 4. Or the other option is to use a number line. Okay, so if that's negative 4, we're going to include it, so a closed circle, and we indicate by filling in that left portion of the number line. Okay, so you'll take a look at the notes later on, but essentially a linear inequality is solved in the exact same way as a linear equality or a linear equation, with the condition that if you're dividing or multiplying by a negative number, you have to